Intel may be one of the best known CPU manufacturers in the world. It had huge success in the PC market, both workstation and server, but when it comes to processors for mobile devices, well, Intel has been a lot less than successful. But it didn't have to be that way. At one point, Intel had everything it needed to make a huge success in this market, and then it gave it away. Yep, it's time to look into Intel and their forays into the mobile market. But before we get into the nerdy details, it's time to have a quick word from our sponsor, PCBWay, fine purveyor of printed circuit boards. If you've designed a PCB you would like to get made, or you've had someone else design a PCB that you would like to get made, you upload the design to their website, give them money, and PCBs will come back in the post. You can also send them 3D model files, and 3D printed things will come back in the post, or CNC things will come back in the post, depending by and large on which combination of buttons you clicked. To understand the seeds of how things went a little bit wrong for Intel in this market space, we're going to have to go back in time a little bit. Intel has released the Pentium processor and made a huge success of it. With PC ownership starting to explode amongst the general population, the PC is encroaching into every market segment. It's starting to eat the lower end of the Unix workstation market, it's starting to get a foothold in the server market, and PCs are displacing special purpose machines focused more towards, for example, the educational market, like Acorn's Archimedes series. And these events caused things to change for Acorn Computers in Cambridge. They'd had the previous model, the BBC Micro, that was incredibly successful in schools. But their sequel set of machines, the Archimedes, were not doing as well. Schools were trying to standardise more on the PC because that's what kids would experience in the wider world outside of schools. Despite the fact that in many ways the Archimedes is a bit technically superior, particularly when it comes to the processor, the ARM. A number of cost constraints on the ARM CPU had meant that Acorn had needed to design it in such a way that it could fit in a plastic package rather than a ceramic one. This meant it could not get too hot, which in turn means you can't draw much power because power becomes heat. So what they'd made is a very power efficient chip for the work that it's doing, so it wouldn't melt itself out of its own plastic housing. After all, they were designing a CPU and not a kettle element. But with Acorn increasingly struggling to find a market for its machine, it's fair to say that Acorn were looking for other things they could do with their ARM processor. Acorn itself, for example, was trying to diversify into set-top boxes. So when Apple came calling looking for a processor for their brand new Apple Newton, a product that famously did not sell overly well, Acorn was very welcoming of the idea of Apple making use of it, and with Apple and VLSI, they started a company called ARM Limited. Now, the idea of this organisation was to license out their CPU design to other companies that wanted to build products around it, rather than Acorn being the one that has to build the product. Now, this change is absolutely vital to the success of the ARM microprocessor going forwards, because unlike Intel, ARM was not going to make the chip themselves. They'd licensed the design, other chip manufacturers could incorporate their things into it and get another foundry to make the chip. Whereas with Intel's model, they completely design a fully functional standalone chip, they make it and they sell it to you. If you want anything integrated with that, well, you do that on a printed circuit board. You don't get it in the die of the processor. Now this happens at almost the perfect time, because as they're doing this, a mobile phone market is starting to appear. It goes during this period from being something that belongs to maybe the odd incredibly wealthy person and is about the size of a suitcase, to a handheld brick-sized thing that we can all carry around and use that becomes relatively affordable. And a big part of what made them affordable is suddenly they start having microprocessors in them that can do all the work, eliminating a ton of logic. And the chips that start to power these devices are all, by and large, ARM devices, with companies like Texas Instruments, for example, getting a license off ARM for the processor design and then incorporating their own stuff around it. So, for example, the ARM7 TDMI chip from Texas Instruments becomes hugely popular inside a whole bunch of mobile phones. And the reason they're popular is you can do quite a lot with them with surprisingly little battery draw. They also pop up in devices like the Game Boy Advance. Texas Instruments also has another big success with their follow-up set of OMAP ARM processors, which basically powers every single Nokia phone out there, who happens to be the brand that sells the most mobile phones during this period. But also, it's not just Nokia that are using these chips, it's practically every phone manufacturer out there. Now, initially, this is a relatively small niche market that Intel, by and large, just ignores. But this means that ARM's busy building a relationship with a whole bunch of component suppliers and other chip manufacturers and designers, and each of these CPUs made by a third party, well, is cramming more and more bits of their IP into that chip. And why Intel's ignoring this market, all these relationships and integrations means that at some point if Intel decides it wants to be part of this, well, it's going to have a relatively high barrier to entry. In not seeing the importance of this market, Intel is effectively a little bit asleep at the wheel, but it is having a lot of success elsewhere. And that success, well, leads to something rather interesting. Eventually there breaks out a bit of a patent bun fight between Intel and DEC, Digital Equipment Corporation, over a number of features that Intel's included in its Pentium line of chips. And of course Intel decides to countersue for patents it thinks that DEC has violated. Now eventually all this legal action does not go DEC's way. I think a big chunk of that is because DEC was kind of struggling for money at the time, so it didn't really have the financial wherewithal for the fight. But in order to settle this, DEC ends up transferring the IP ownership of its strong-arm processor to Intel. Now, DEC had seen the advantage of having an ARM chip in its lineup of products, because it did want a small, very capable CPU available for doing various embedded compute tasks, and thus it had licensed the ARM instruction set off ARM and built itself its own CPU, the Strong-Arm, which at the time was the most powerful ARM chip you could lay your hands on. Now, this was the first time that ARM had actually licensed just the instruction set and not the whole chip design, so DEC designs the chip and they implement the ARM instruction set, much like Apple do now with its famed Apple Silicon. But this means once this property transfers to Intel, not only is it an ARM licensee with rights to use the instruction set, it also has its own unique ARM chip design that is quite a bit ahead of all the other options out there in terms of performance. Now, this is where Intel could have made a bid to really capture a large chunk of this market, because it has the chip and chip design, but Intel, being one of the largest silicon foundries in the world, also has an industrial might that they could make use of to really hammer down pricing and take over quite a lot of the market. Does Intel do that? Does it? Yeah. So what does Intel do with its newly acquired ARM technology? Well, for a start, it renames it Xscale so no one has a clue what it is. They add an MMX extension to it, which is totally its own proprietary thing. That means if any manufacturer uses this thing, they'll be incompatible with the whole rest of the ARM ecosystem, which does not help them sell product, because other companies have seen how Intel essentially booby traps this stuff so they end up becoming dependent on Intel's products. So they choose not to embrace it. But also, there's no particular compelling reason to use it. Why the Strong-Arm is the fastest ARM chip out there, unless you're building a computer around that ARM chip, well, the other ARM chips are more than fast enough to be a mobile phone. Now, Intel could have used its large industrial base to cost reduce this thing and, make them a lot cheaper. But Intel didn't do that. ARM chips they're already using in devices are still cheaper per unit than Intel's offering, and it comes with a lot less strings. So you might be thinking, what did Intel do in this space? Well, the answer is for quite a while, relatively little. It just let this Xscale version of Strong-Arm continue on for a while. They were distracted on other things, largely their pursuit of desktop and server CPUs, and laptop to a certain extent, although laptop did become more important as time went on. But it's fair to say that Intel had got to the point where it is a bit of a sprawling mess in need of a bit of restructuring, and at this point, all around the same sort of time, that a couple of key important events happened. Having not really done anything with their ARM license, Intel decided it was going to sell that Xscale part of the business off because it had been losing money for a relatively long time, and sold that to Marvell. But they also, as part of enabling that sale, decided on their strategy for mobile. And they went with the assumption that in the future, mobile devices would want more compute power than they currently had. And of course, to them, that meant people would start using x86-based chips inside mobile phones if only they could be made close to power efficient enough. After all, who would want all this ARM stuff when you can have a proper CPU? Because Intel was having a bit of a phase of not invented here syndrome. If a technology didn't originate with Intel, they didn't really seem to be interested in the way that they were in their own stuff. After all, Intel didn't invent it, so it can't be as good as the stuff that Intel invented, which kind of ignores a lot of Intel's history of not actually inventing the products of it that became successful. But yeah, the next decision in this mobile space probably will be the millstone that will be hung around the neck of Paul Otellini for anything that ever mentions what he did at Intel. Now, apparently Ottolini was one of the main driving forces behind getting Apple to switch away from PowerPC to Intel-based chips, thus meaning that the only real supplier to the PC and laptop market were the producers of x86 chips. The last alternative architecture that was shipping in any volume to that market space, well, that was it. It was losing its only customer, Apple. But shortly after that great business move from Ottolini came a less good one. Apple approached Intel to be the supplier of the CPU for its new mobile phone device. After all, the bigger volume they had with Intel, the bigger discounts they'd get. And apparently Ottolini thought this device would not ship in sufficient volume, it's not worth producing a chip for it, and besides, they're selling off the Xscale business. So Ottolini and Intel said no. Now, as we all know, the iPhone went on to be a little bit successful, being really the first smartphone that kind of truly lived up to the title. It wasn't just a PDA that made phone calls. Now, this device and the other smartphones that would follow it would represent that turn in the market that Intel thought was going to happen, that people would suddenly want much more capable processors in their mobile devices. It's just this trend started off with ARM and not Intel. Intel's strategy of, we'll have an x86 chip ready for when that happens, that won't be a kettle element and burn its way through your pocket whilst eating your entire battery, well, that wasn't going to be ready for a while. And ARM had chips that were quite powerful, they just didn't eat the same quantity of electricity. It's not like Intel had made no low-power processors before. Well, lower power than their desktop stuff, I should say. And AMD had their Geode line of chips, which were again x86 class processors, 32-bit, didn't draw as much power as their regular processors, and obviously didn't perform quite the same as their regular processors either. Now, Intel also had their A100 and A110 processors, which were low-power chips based on the Pentium M architecture, but they don't hit the performance point in terms of processing power, and they also don't hit the performance point in terms of the electricity that it consumes. But everyone knows that Intel is working on something. They've been talking about it for a really long time. How they definitely crammed their entire x86 CPU compute power down into something small and battery efficient and not slightly warmer than a cheese toastie you've left in for too long. The problem is, though, why Intel's still talking about and announcing things that they are going to do and what the future of mobile computing is going to be, the future of mobile computing is already here, and it's got an ARM processor in it made by Samsung. By 2008, we have the first Android phone, followed by a lot more Android phones, and of course the iPhone's been out for a year or so. Intel, they've still got nothing. Or nothing that anyone could use in mass production. By April 2008, they had shipped a development kit that contained the first Atom processor to the first company that had ordered it. That does not a viable product make, unfortunately. So we still have to wait a while until anyone can buy a device that's got an Intel Atom in it. But eventually we do get them. For example, Dell made a little mini tablet type thing that featured the Intel Atom. Now you might wonder, what is this operating system going to run on if all the other ones are running on ARM? Well, this is where we also see the emergence of Android for x86. And to be honest, that is the only mobile operating system we're really going to see for them, as there is no way Apple's going to port iOS over to this thing. They are happy with the hardware they've got, thank you very much. But also, Android does have a bit of a portability advantage, in that Android is a Linux kernel with some extra modules in it, a Java virtual machine, and a couple of native classes that make some of the Java a little bit more efficient where it really needs to be. They're basically all the processor-dependent bits of the operating system you have to port. Linux already runs on x86. There are plenty of JVMs for x86. And those native classes, well, given that they're built to compile on top of Linux, you just kind of have to recompile them rather than rewrite them. Now, all your applications that you download, they're all in pure Java bytecode, so they just work. Your app vendor doesn't have to worry about compiling it for x86, they just target the virtual machine, and that makes it run on ARM, which, to be honest, is still the target it pretty much only ever runs on, and on x86. Now, you might be wondering, what did this thing perform like? After all, it's got a desktop full PC kind of a chip in it, right? Well, why I don't have one anymore, I did get to tinker with one back in the day, and you know what? It's kind of alright. It's a bit Yeah, it didn't really perform any better than any of the ARM-based things I had that were running Android. In fact, to be honest, it performed a little bit worse at sometimes. There were more random little pauses every now and again. And you won't die of shock to learn that the battery life also wasn't as good. Yes, this was the culmination of all of Intel's strategy with regard to mobile of everything's going to go x86, right? Yeah, well, obviously it didn't. And there was more cost in making these devices. Firstly, this is not a system on chip. This is a processor and a chipset for the board. Whereas some of these ARM chips, well, they have basically everything you need to run the machine inside one chip. The RAM controller's in there, the L screen controller, everything. It's all just in one little package. This meant these devices could be made cheaper. They were also more power efficient. And performance-wise, they were no worse, and in some cases a bit better than Atom. Did this stop Intel from going down the same route and continuing with more Atom processors? Did it? Yeah, for some reason, Intel seemed to think of ARM as a bit of a toy processor. But when it came down to it, the little toy processor was beating their effort. And with each next generation of Atom, the gap actually widened between it and ARM. Less and less manufacturers wanted to bother building an Atom-based solution. Where they have done quite well is in the NAS market, where x86 compatibility is considered useful, and also really low-end PCs. Their Atom has found a life for itself, but not in the mobile devices. So let's have a look at the couple of generations they've managed to release of Atom so far. Now, for the first generations of Atoms, they did actually have a number of slightly different variants of them aimed at different sectors. So you had the ones aimed at the more handheld ultra-mobile devices, which were the Silver Fawn, that had a little GPU built into it, and is very 32-bit, and then you had the ones aimed at very low-end PCs and netbooks and nettops, that sort of thing, the Diamond Film, which did not have a GPU in it. In 2010, we see the next set of Atom processors. In the ultramobile sector, we have the Lincroft, which is more or less the same as its predecessor, but it now has a GPU that runs at twice the speed. It's still fabricated on a 45nm process, and it's still a 32-bit CPU. On the low-end PC side of things, we have Pineview, which introduces their GPU into that line of products. And they ship that in a single-core and a dual-core version, and with a 200 and 400 MHz GPU. Now, in 2011, we see some updates to the low-end PC net top end of the market chips, with the code name as CedarView, and they are all dual-core now, and the two GPU speeds available are 400 MHz and 640 MHz. But this is also the year we see them not release something for the ultra-portable end of the market, i.e. competing with ARM. There's no new processor in 2011, and there's no new processor in that space after that from Intel either. In 2012, we do see them release a version of Atom that's targeted more towards the storage server end of things, i.e. to go in your NAS box, because a few vendors had been using their low-end PC version of the chip, and they'd sold quite nicely, so Intel had realised that there was a market there, so they actually produced a series of Atoms for that market, and they all start off as dual-core on a 32nm process, and they're all 64-bit by default rather than 32-bit. Now, some of the earlier Atoms did have the idea that you could optionally enable 64-bit if you connected enough pins up, but many were not deployed that way. But on these, you did need 64-bit in terms of how it accessed the memory. The other key part is they built in things like the SATA logical interface, same with the LAN, into the chip itself. You still need an external physical chip attached to it that would do all the electrical signaling for your Ethernet and your SATA and provide all the electrical protection so you couldn't just murder your CPU with your Ethernet port. But this meant building a NAS around this thing was a lot easier for the people creating the board and, a lot less additional extra hardware to go with the CPU. And we would see them do a second generation of these in 2013, with some models even going up to 8 whole cores. And they dropped this down to a 22nm process by then, which did let the clock speeds go up somewhat. And peak draw for these was around 20 watts, which is not bad for what it's doing. I mean, it doesn't compete with ARM's performance per watt, but it's about as efficient as you're getting with the x86 instruction set. Now, someone probably will get annoyed with me if I don't mention the clock issue, because the clock issue's become little famous lately. Yes, following in a long tradition of, well, Intel screwed that one up then, didn't they? Turns out all the Atoms do have a little bit of an issue. Now, Cisco first reported it apparently in 2017, or at least that's the first reference I can find to it, and this only affects really the later system-on-chip variants of the Atom that would come out, and it's to do with the generation of the clock signal. Now, with a system-on-chip, you're trying to sort of throw in all the additional bits of hardware you'd have around a processor into one package to save on cost. And that commonly includes the generation of the clock signal that's used by the CPU and the other chips to synchronize what they're doing. And what happens is, while your clock may be running fine, at some point you will shut your machine off and start it again, and the clock won't start. And that means no other parts of the SoC will come up because there's no clock. so that machine will never boot ever again. So for any of us who've on these Atom-based CPUs in the machine, one day, on these little system-on-chip ones, you're going to turn that machine off and turn it back on, and it's just not going to happen. And it's not something you're going to be able to repair because it's on the die of the CPU. So it's not something, unfortunately, that us retro tinkerers at home are going to be able to repair. So when you see me panically posting on Blue Sky that my Synology NAS has stopped working randomly, you know what killed it. So there we have it, how Intel could have been a player in the mobile market. After all, it did own the best implementation of the ARM chip out there at one point, to trying to have a go at taking over the mobile processing market with a not-so-brilliant x86 chip, to then completely giving up on the mobile market all over again. But accidentally discovering that they've made an alright processor for the NAS market that will eventually self-destruct, killing your NAS. If you got all the way to the end, I'd like to say thank you very much for watching, and also putting up with the fact that I've had a bit of a cold through a large part of the production of this. If you enjoyed the video, well, YouTube's created a button that you can use to indicate that fact. There is also another button of which we shall not speak. If you'd really like to help the channel out, there's the subscribe button, which when combined with the bell icon will do the thing that you probably hoped it was going to do when you clicked it.